In the vast digital void, we face a fundamental question. How do we find a specific word, hidden inside another? Consider the string sadbutsad. We are searching for sad. It appears right at the beginning, at index 0. But what if we search for leeto inside LeetCode? The pattern doesn't exist. The system returns -1. Leads to algorithms used in search engines. We need the index of the first occurrence of needle inside haystack. First window already matches. So answer is 0. No window matches. Return -1. Start from every position. Compare the next characters. If all match, return index. We only check windows where the full pattern can fit. Here is the Python implementation. Loop through every possible start. Compare substring. Match found. Return immediately. This is the brute force approach. Simple. Elegant. But be warned, the time complexity is n times m. Worst case. Check every position. Compare every character. Space complexity is constant. Interviewers may ask for KMP. It skips useless comparisons. That turns brute force into linear time. Here is the Java implementation. Note the use of substring and equals methods. This tiny problem powers massive real-world systems.